Hi, welcome to my video on the summary of inverse trig functions. I'm going to review the inverse trig functions, but the order that I'm going to do it in is not the same order that I did the videos previous to this. I'm going to do sine, cosecant, and tan, cos, secant, and cot. And there's a reason for that, and I'll explain as I do them. So y equals sine theta, and so sine is related to the y, or is the y on the unit circle. So this is the unit circle here, whose radius is 1. So this is 1, 0, 0, 1. This is negative 1, 0, and this is 0, negative 1. So sine is the y. So at 0 degrees, the y is 0. At 90 degrees, the y is 1. At 180 degrees, y is 0. At 270, y is negative 1. At 360, y is 0 again. So this is the sine graph. I'm going to put the sine graph as a dotted. There's the sine graph. And it continues on to negative 1 to 0, etc. So there's the sine graph continuing. Now, we want, notice that if we, let's continue, just as well to continue. Here we go. There it is. If I draw a horizontal line through this graph, then the horizontal line passes through more than one point. So that means we have to restrict the domain. We have to restrict the values of theta. And those values that we restrict for sine are, we're going to restrict them from negative 90 to a 90. So we're going to restrict them from here to here. There they are. So the black is the restriction. So when we do that, notice here that we have the domain is from negative 90 over to 90. Theta is in the middle, and it's equal to negative 90, equal to 90. So it's less than or equal to theta, less than or equal to 90. And the range is from negative 1, less than or equal to y, less than or equal to 1. Okay, now, I did up a little sheet to show you right here. Right here I have this restriction, which is this black right here. There it is. So if I take hold it on at the end, so this is the line going up through the middle doing the reflection. I'm reflecting this line, so I'm going to turn it over. There it is. And there's his inverse. Now, what I'm doing, I'm not looking at his inverse, I'm looking at the restriction, because the restriction is easier to see in his inverse. So what happens is that your domain becomes your range, and your range becomes your domain. And in relation to the restriction, notice that if I take values between 0 and 1, I'll get an angle between 0 and 90. If I take a value between negative 1, between 0 and negative 1, I'll get an angle between 0 and negative 90. So let's look at the inverse of sine. So let's go inverse sine of a half, which is 0.5. And what do we get? We get a 30-degree angle. And what about the inverse sine of a negative a half? So if I go and put in negative 0.5, and I get negative 30. And that's 30 degrees is pi divided by 6, and negative 30 degrees is negative pi divided by 6. So 180 divided by 6 is 30. So 30 is pi over 6, negative 30 is negative pi over 6. Okay, let me move my calculator now. And notice that because we have a positive number, that means the positive number is here. That means the angle is going to be between 0 and 90, 30. Because I have a negative a half, which is right here, then this angle is going to be right here, and that's between negative 90 and 0, and so it's a negative 30. And I just showed you by using the calculator that this is so. Now, what about cosecant? Let's look at cosecant. Cosecant is 1 over sine. So that means that whatever the restrictions on sine is on cosecant because it's the reciprocal. So sine is 0. If I, again ahead of myself, let's draw the sine graph again. So here's the sine graph. 0, 1, 0, negative 1, 0. We got a 0 goes to negative 1, 0, 1. So this is the sine graph, and it's a sideways S. And we learned this in the sinusoidal function, but I keep practicing it here because I need to know what this is doing. So there's the sine graph. So sine is undefined at 0, which is right here. Sine is undefined at 180. So sine is the y, so it's at 0 and 180. And all multiples of 180. So that's undefined at 360, etc. So the cosecant graph is reciprocal. So that means because its sine is positive from here to here, its reciprocal is doing this. It's a u going up. And this is negative here, so its reciprocal is negative 1 and going down. Okay, but we want to restrict it. So when we restrict it, we have to take, again, this is negative 90 to a 90, so cosecant is going to be negative 90 to a 90. So the restriction is right here and right here. So the dark line is the restriction. Oh, make that. So there's the restriction. And what we've done is that the domain is the same. The domain is negative 90 less than or equal to theta. That's a theta there. I got a 0, theta, less than or equal to 90. And they're degrees. Just make sure they're degrees, not numbers. And the range will go from, the range is going from, now let me do, the range is starting at negative 1 and going down. So y is less than or equal to negative 1 in union. Union is it's included. U in union is u, so it's, and the y right here is greater than or equal to 1. So that's, now, if we take this graph, again, I'm going to use my piece of paper. So this is the graph right here, this graph. I have put it here, there it is, and here, there it is. So I'm going to do the reflection again. So here we go. We pick it up, and I reflect it in that, in this line. Again, I reflect it in this line going through the middle here. So here we go. We turn it over like this, and there's his inverse. So as you can see, it's reversed, and this line is not there. And I forgot to put that this line is a vertical asymptote. So that means that theta cannot be 0. And so that means that y can't be 0 here, because that's the vertical asymptote. This is the horizontal asymptote. So note, but how I learned it, or how I did it, is that I relate sine is from 90 to negative 90 to a 90, cosecant from negative 90 to a 90, and I keep that in mind. So I go sine, cosecant. So let's look at cosecant, the inverse of cosecant when we have a 2, because notice the inverse, we have a number, so we're coming up with an angle. So inverse of if cosecant is 2, that means sine is a half. So that means we're back to here. So that means we got a 30-degree angle. And the inverse of -2 is negative half. So this is a negative 30, same answer. So that's a pi over 6. And that's a negative pi over 6. You want degree. I always put it in degrees first, and then I change it to radians after. Okay, let's have a look at tan. Tan is sine over cosine. So tan is undefined where cos is 0. And cos is 0, cos is the x, cos is 0 at 90 and 270. So at 90 is the vertical asymptote. At 270 is the vertical asymptote. And at negative 90, you got every 180 degrees, you got vertical asymptotes. But the tan graph, it goes from here through to 0, like this. And another one comes down, goes through 180, because the tan of 180 is 0, the tan of 0 is 0. So the tan graphs are doing this, but again, we have to do a restriction because fails the horizontal line test. The horizontal line goes through many points. So the restriction on the tan graph to do an inverse is this one right here. There it is, this piece here. There's a restriction. And again, that restriction is from negative 90 to a 90. So the domain is negative 90 less than theta less than 90. Notice this time, these are asymptotes, so you can't use the negative 90 and 90. And the range is all reals for the y's because they're all positives, 0, all negatives, so it's reals. Okay, now we have to look at the inverse of that. So here we go. There's the graph right here that I restricted at. There it is there. Here it is right here. So I'm going to pick it up and do its inverse by reflecting in this line going through here. Here we go. Turn it over. Watch. And its inverse is right here. Again, it's undefined at 90 and negative 90. So the domain becomes the range, and the range becomes the domain, reversed. Okay, so let's use our calculator. Let's use our calculator. And what about if we use the inverse tan of 1? So the inverse tan of 1, tan that's positive. So positive to 1 is right here. So the angle is between 0 and 90. And the arctan is the same as tan of negative 1 up. The arctan of negative 1 is right here, so the angle is right there between 0 and negative 90. So let's use a calculator. The tan of what angle gives you 1? So we turn on our calculator. There we go. Inverse tan of 1. There it is. I'm using my calculator to verify. And it's a 45 degree. And 45 degree is 180 divided by 4. And the inverse tan of, let's go back there, get negative 1. And we got negative 45, which is negative pi over 4. So let's move the calculator. Make sure I don't squish everything around here. Move my calculator. And so the tan is on the 45 is the two sides are equal. So that's why the tan of 45 is 1. Tan of negative 45 is negative 1. Notice that tan is this is in the first quadrant, 0 to 90, and this is in the fourth quadrant, but it has to be a negative angle. To be in the fourth quadrant, you can't say it's going to be 315 because it's got to be between 0 and negative 90. So that's why it's negative 45. Negative 45 is in the fourth quadrant. Okay, so notice again, sine, cosecant, and tan have the same restrictions from negative 90 to a 90. So when a number is positive, it's from 0 to 90. When a number is negative, it's from 0 to negative 90 for the angle. And that's why I put the three of these together. And I have these memorized, how they fit. So what about the cos graph? The cos graph is related to the x. So the cos of 0 is 1. The cos of 90 is 0. The cos of 180 is negative 1. The cos of 270 is 0. The cos of 360 is 1. So the cos graph is a sideways. Whoops, let's go and make it dotted. There it is. There's the cos graph. And I'll keep on going. So it goes down to 0, down to negative 1, and it goes up to 0, up to 1. So there's the cos graph, continuing on. But we have to do a restriction. So how do we restrict the cos graph? Well, I know that sine is restricted from negative 90 to a 90. So the cos graph is restricted from 0 to 180. So the dark is the restriction on the cos graph. Because if I draw a horizontal line, it passes through many points. So I have to restrict it in order for its inverse to be a function. So it goes from 0 degrees right here up to 180. And so that means your domain is going from 0 to 180. 0 less than or equal to theta, less than or equal to 180. And the y is going from negative 1 less than or equal to y less than or equal to 1. It's equal to negative 1 and equal to 1. So let's have a look at the inverse of that cos graph that I have done previous on a sheet. So there's the cos graph. There's the piece I'm picking. Here it is right here. And I'm going to flip that. I'm going to reflect it in the line going up to the middle. Here we go. Twist it over. Watch it. Here it is. And there's his inverse. So his domain becomes the range. So notice right here from 0 to 180 is theta. So theta is from 0 to 180 here. And the range is from negative 1 to 1. So there's the negative 1 right here going to the 1. So there's the curve of its inverse. But again, I learned where the restriction is. It's easier to learn where the restriction is. And let's use our calculator and look up. Let's see if I'm going to move this up now and show you. Here we go. We're going to do the restriction. What about we have a half? So before I show you the calculator, a half is positive. So when a half is right here, so when it's positive, the angle is here. That means when the number is positive, the angle got to be between 0 and 90. And when the number is negative, the angle is here, which has to be between 90 and 180. So let's verify that. The cos of what number? The cos, the inverse of a half gives you what angle? So let's do the inverse. Make sure you see the calculator. Good. So inverse cos of a half, which is 0.5, we get a 60-degree angle. So if you draw your 30, 60, 90 right triangle, cos is adjacent over hypotenuse. So again, the adjacent side is in terms of the 60. And 60 is 180 divided by 3, pi over 3. And what about the inverse cos of a negative a half? What do we get? We get 120. And 120 is pi over 3, which is 60, but there's two of them. Now you can multiply 120 by pi over 180 and reduce it down, but notice I got a 60 here, which is the reference angle. So 120 is 2 pi over 3 because it's two 60s. Okay, move my calculator. So notice now that cos is from 0 to 180. Notice that sine, cosecant, and tan is from negative 90 to a 90. Now let's look at secant. Secant is 1 over cos. And cosine is 0. Cosine is 0. Cosine dx is 0 at 90 and 270. So at 90 is undefined. At 270, it's undefined. At negative 90 is undefined. So this is a cos graph, and the cos graph is doing this. So a cos graph is, here's the cos graph. I'll put a dotted for the cos graph. And it is 1, goes down to 0, goes down to negative 1, goes back up to 0. So there's the cos graph. Now we have to do a restriction. And the restriction, or sorry, not a restriction, sorry. Now I have to do the secant. So that's the cos graph right here. So the secant is the reciprocal. So in this interval, the reciprocal of 1 is 1, and the reciprocal of these positive numbers here is going up here. So it's the same as this one, only it's positive and negative, etc. But the restrictions in here is negative 90, 90, and, the restrictions are 0, 180, 360, negative 180. Restrictions here are at negative 90, 90, 270, etc. Now this is the negative 1, so it's inverse of these numbers here. These numbers are between 0 and 1, so the inverse has the secant graph doing this. So if I do the restrictions now, so the restrictions is right here. Because if you draw another one of these, which is like this, let's say that's there. If you draw this one, remember it fails the horizontal line. It fails the horizontal line test because it passed through many points. So I have to do a restriction. So when I do cosecant, I know the restriction is on negative 90 to a 90, and when I do it here, it's what? It's from 0 to 180. So cos is from 0 to 180. So secant is going to be from 0 to 180. There's the restrictions. And that means the domain is the same as here. It's 0 less than or equal to theta less than or equal to 180. But the only difference here, that I can have a 90 here, but I can't have a 90 here because this is an vertical asymptote. So that means theta is not equal to 90 degrees. And we have the same, the range for cosecant is the same as the range for secant. But instead of writing these down now like this, what I'm going to do is put them in the interval notation. So that means I'm going to put them in at like this, starting at negative 1, going to negative infinity. So that's equal to negative 1 going to negative infinity. So that's the same as this right here. In union is u, and it starts at 1, square bracket is equal to, going to infinity. And that's open. The square bracket is equal to, open, this is open. And again, let's look at the secant, arc secant, or secant to the negative 1 up to 2. So the reciprocal of secant of 2 is the cos of a half. So that gives us the same answer, 60, which is the pi over 3. And the arc secant of negative 2, the reciprocal of negative 2, secant, the reciprocal is cos, so cos is negative a half, the same as here. So we get 120. And that's 2 pi over 3. So again, notice it's positive. So when it's positive, we pick the angle from first quadrant from 0 to 90. When it's negative, we pick the angle when it's negative, negative is right here. We pick the angle from 90 to 180. Okay, let's have a look at what cot is doing. Oh, well, I don't think I did inverse of the secant. Here's the secant, restriction here, there it is, and here, there it is. So I'm going to take it and I'm going to do the reflection. Oh, I got to bring this back down now. I got to bring it back down. Bring it back down. Here comes the reflection. And there it is. So it's going from -1 downward, starting at the 180. And here's going at, starting at 1, x is 1, going to positive infinity. Okay. Trying to notice I got it all on one page to show you how to remember. Now let's do y equals cot. Tan is sine over cos, so cot is the reciprocal of cos theta over sine theta. So cot is undefined when sine is 0. So y, sine of 0, y is 0. So y is 0 at 0 and 180. So it's restricted at 0, vertical asymptote, 180, vertical asymptote, 360, vertical asymptote, negative 180, vertical asymptote. So I know that tan goes this way. So I know that cot goes the other way. So there's the vertical asymptote. Cot starts here and goes the other way. And so the cot of 90 is 0. And again, it goes the other way. There's, just draw a couple of them. And we're doing one more. So there they are. And again, it fails the horizontal line test because it passes through many points. So the restrictions, tan is from -90 to 90. So cot is from 0 to 180. Notice again, cos, secant, and cot are all restricted from 0 to 180. Okay, let's look at the domain. The domain, you can't have 0 less than theta less than 180. You can't have 180, you can't have 0 because they're vertical asymptotes. And the range is reals. And before I forget it, let's do the reflection. So here's the graph. Here's the piece right here. This is the piece I'm restricting it at. There it is. Okay, now I'm going to reflect it. And when you reflect, you're reflecting into that. There it is. So there's the reflection. So there's horizontal asymptotes at 180, horizontal asymptotes at 0. And I have some more numbers in. And so this point here is 90 degrees and 0. So right here is 0 and 90 degrees. Okay. And want to look at the calculator on cot of the reciprocal of cot is tan. So reciprocal of cot is tan. So the tan reciprocal of 1 is 1. So cot inverse, cot to the -1 inverse is the same as looking at the tan. Where's the tan right here? So you get a 45. Because it's positive, positive number is right here. So the angle is between, again, 0 and 90. So the 45 is pi divided by 4. 180 divided by 4 is 45. And the tan to the -1 is the same as cot to the -1 because the reciprocal of cot is tan. Reciprocal of -1 is still a -1. So that's -45, which is -pi/4. And again, cot if you've got a positive number, which is here, you're going to get an angle between 0 and 90, first quadrant. And if you've got cot is negative number, inverse of negative number is here, so your angle is here, which is between 90 and 180. So again, just as a little recap, sine, cosecant, and tan are restricted between negative 90 and 90. And cos, secant, 1 over cos, cot is cos over sine. They're all restricted from 0 to 180. And one more little comment I just want to make. Y equals, now I'm going to put TF, trig function of theta. So if you have, say, right here, y equals cos theta, that's y, that's the cos theta, so that could be cos theta, secant theta, cot, tan, any one of them. So that's the normal, and his inverse is theta, and of the trig function to the -1 of the y. So here you have, this is theta, which is in degrees, this is a number. So this is degrees, this is a number. When you reverse it, this is a number, so the inverse of the trig function in terms of the number gives you an angle. And the angles, again, sine is between -90 and 90. And cos is between 0 and 180. I hope that explains how the inverse is done. Again, I do it from the point of view of the restrictions. It's easier to see rather than try to look at the graph of the inverses. So I've memorized this. And that brings us to the end. And if you like my video, click on the like button, click on the subscribe button. If you wish, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, which is just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.